everyone and everyone. Today we're going to be solving a mathematical problem on optimization. In our problem, we have to construct a box using a rectangular thin sheet by cutting 4 squares in each corner of the sheet and fold up the sides. So suppose the box is in 7 inches in length and 5 inches in width. Here we have to determine the height of the box given the maximum volume. So given we have a length of 7 inches and a width of 5 inches. However, in order to solve this problem, we have to remember that each of these cut portions of the corner represent the length of this rectangle. So we have to cut them out and consider them as all x's. There. Now, say once we've cut these out, such as and fold up the box, it would look similar to something like this. This is the box when folded up, wherein this area is vacant but an open space. Here we can then write our equation as the length as 7 minus 2x. So again, taking out x's, each of the portions, and in here, 5 minus 2x. This accounts for the length, while this accounts for the width. However, if we were looking for the maximum height, we can represent this whole thing as x. Moving on, lacking space, I shall not move here. We can then write our equation as, first we have to remember that if looking for the volume of a rectangle or of a box, we have to remember the equation length times width times height. Having our values here, we can substitute as length, which is 7 minus 2x, width 5 minus 2x, and then our height as x. In order to solve this, you have to move further on and combine and multiply within the bracket. Therefore, it would appear as 35 minus 14x minus 10x minus 4 plus 4x squared. Multiply to x. So what's within? We get 4x squared minus 24x plus 35 all multiplied to x, and as the final answer for this equation we get 4x cubed minus 24x squared plus 35x. In order to further solve this problem, you have to now derive this equation, wherein v prime to x, it would then become 12x squared minus 48x plus 5. Now, in order to find for the maximum height of this, we now have to equate v of x to 0. So v prime of x now equal to 0. Hence, this shall become 0 equals 12x squared minus 48x plus 55. Since given that we already have our roots over here, we can no longer simplify it any further or break it down. So instead, we can make use of the quadratic equation. And you remember that the quadratic equation is negative b, positive negative, square root of b squared minus 4ac over a. Given that our 12 is a, our b is negative 48, and our c is 35, you can simply substitute into the quadratic formula, giving us negative 48, positive negative, the square root of negative 48 squared, minus 4 multiplied to 12, multiplied to 55, over 2 multiplied to 12. In solving for this quadratic formula, we should have arrived at the answer of 48, positive negative 4, square root of 39 over 24. Further solving this, we will get the answer of 2 positive negative square root of 39 over 6. Now, we are left with two possible answers for x, wherein x would be 2 plus 39 square root over 6, or x equals to 2 minus square root of 36 over 39. How do we determine which one is which? Now you remember, we have our roots here. To simply determine that, we could again equate v of x to 0, as we've done here before. And equating it to 0, we would get 7 minus 2x, 5 minus 2x, x. We solve it in the basis of x, where it would look like 7 minus 2x equals 0, 5 minus 2x equals 0, and x equals 0. In doing so, our x of 1 will be 7 over 2, while our x of 2 will be 5 over 2. If you were to apply that into a number line, wherein this shall be our 7 over 2, and this shall be our 5 over 2, if we were to draw it as such, and this shall simply be our x, as equaling to our height, we can see that all of them meet within this particular range, within 5 over 2, otherwise being 4 and 1/2. That being said, we can then tell that our x should be greater than 0, but less than 5 over 2. That being said, if calculated, our first x would reach an approximate of 3, while our second x, which is minus, would reach an approximate of 1. Therefore, this shall be our final answer. Thank you for joining us. I hope you understand, and have a good day.